On today's quiz, you were to sketch or write a table for y equals 5 to the x. That's 5 to the plus x because in my distraction I wrote 5 to the negative x for some reason and changed that to a plus. But it's 5 to the x. And we're to use this table then to construct a graph of log to the base 5 of x, and then to sketch a graph of the 5 to the x function and the log to the base 5 function. So you should stop and do that yourself before you go on. Now, if we make the table, we let x go from -2 to 2. Actually, I wrote down 3 there, although we're not going to be able to graph this point because of the 125. If x is -2, then y is 5 to the -2, which is 1 over 5 squared, which is 1 over 25, or 0.04. If x is -1, of course, y is 5 to the -1, which is 1/5, or 0.2. 5 to the 0 is 1. 5 to the 1 is 5. 5 squared is 25. 5 cubed is 125. To construct a table for the log to the base 5 of x, we simply reverse the columns of this graph, or this table. And x becomes 0.04, 0.21, 5, 25. Y becomes the -2, -1, 0, 1, 2, and so forth. And that becomes a table for log to the base 5 of x. To graph the resulting functions, we simply plot the points. Remember the point when x is -1, 5 to the x is 0.2. When x is 0, 5 to the 0 is 1. So we have -1.201. When we have 1, we have 5 to the 1, which is 5. So we have this curve coming up here. When we reverse coordinates, -1.2 becomes 0.2, -1. So we come over 0.2 down 1, we end up with a point down here, -2.1. 0, 1 reverses to 1, 0. 1, 5 reverses to 5, 1. Each of these points is a reflection across the y equals x line. -1.2 becomes 0.2, -1, moving directly across this line at a perpendicular here. An equal distance from this side to this side. Equal distance on this side and this side. Haven't drawn the equal distances real well here. Perhaps a little better here, but I think I missed it there too, but you get the idea. And this is a graph of y equals 5 to the x. This is a graph of y equals log to the base 5 of x. Inverse functions, inverse function graphs.